This is APAC Azure Data Communities Data Day, our first event for this year. This is APAC Azure Data Community is a collaboration between the all local data platform communities in Asia. You can see the logos above. So let me just go to the presentation so we can go. All right. So if you want to connect to your local communities, you can look for them in Facebook. They are in Facebook Meetup group, and some of them also have their own site. The best place to look for them, we do have a Meetup page for the whole group, APAC Azure Data Communities. You can grab the QR code right now on your screen, so you can join the Meetup page. Or another way to look for your local groups is through the Azure Data community. We have an Azure Data Tech groups in Meetup wherein you can search the communities, the existing communities you can see on the screen right now. All those red dots are data platform groups around the globe. So if you're looking for something to join on your local, you can go to the Azure Data Tech groups. A few reminders for our session today. Keep yourself on mute. If you have any questions, you can use the raise hand icon or put it on the chat. We will we will give the speaker some time to answer the questions later on. And there are some evaluation. If you want to evaluate the session that you've just seen, you can go to the evaluation. If you have any questions for the speakers, usually our speakers share their socials, so you can reach out to them or you can course it through the evaluation. And last but not the least, the session is live stream on Facebook and YouTube, and it's also being recorded for later. We are going to post it in the YouTube channel for the group as well as on our teams because now there's a community teams tenant now for all the community. Uh, for example, for Singapore, we are already on the teams. Same with Bangladesh, and all the other groups are starting to come in. So once we have that in place, we're also going to put the sessions on the Teams channel so for you to easily find it. With that, I would like to introduce our first session for today. Our first session is Azure Machine Learning with AutoML. Our speaker is Emil Pastor. He's a cloud solutions architect for data and AI from Microsoft. He's from what I can see, he's been doing data and cloud for the last 10 years. So he's currently based in Sydney, but he's also a fun fact. He's also a Filipino, just like me, and we actually came from the same university from Mapua in back home, back in the Philippines. So I will let him introduce his session and himself. I'm gonna hand it over to Emil.
Very much, Theo. Hi, everyone. My name is Emil. As you mentioned, I'm a cloud solutions architect for data and AI based out in Sydney. Let me just quickly share my screen. Yeah, so I worked with clients across the Asia Pacific in the topic of data governance, management, data warehousing, analytics, and AI/ML. In this particular session, we'll be focusing more on what automated machine learning is and how it's being used, or you can use it via Azure Machine Learning. So we'll have the agenda. Start focusing on the first 10 to 15 minutes, going through the slides on what Azure Machine Learning is, what is AutoML, and basically give you an idea and overview of what it's trying to solve for your organization or for your business problem. All right, so before we start, let's just give a quick overview of the Azure AI landscape. So there are three main key areas within Azure AI. So you have your AI apps and agent for chatbot. You also have your knowledge mining or your cognitive services, and then we have machine learning. So Azure Machine Learning and AutoML belongs to this part of Azure AI stack. And if we focus a bit on what Azure Machine Learning is, Azure Machine Learning provides you a platform. It's a machine learning as a service that provides you ML capabilities across all skill levels. So from hardcore programmers or data scientists, data engineers, to citizen data scientists, to those who's not very familiar with Python or with R. So it caters to different audiences. It also is embedded within the whole ML Ops framework within the Microsoft, and more and more responsible ML or responsible machine learning and ethical AI has become a hot topic this day. So it's part of the overall features also to address the ethical AI or responsible ML. Plus, the whole platform itself is built upon open source software from Jupyter, Python, R, and so on. So going through a bit on the feature of machine learning within Azure. So within Azure, we cater for different domains across pre-trained model. So you don't need to train it by yourself to already have a starting point to begin with in the areas of computer vision, speech or natural language processing. Then we also have for search, cognitive search. And using machine learning, you will also be more familiar. Like you don't need to learn entirely a new tools, right? So the learning curve is relatively low as long as you're familiar with any of this model development IDEs like PyCharm, Jupyter, Visual Studio Code, or even your favorite command line. Then you should be all good within machine learning on Azure. And for more advanced deep learning solutions, we also cater for different open source frameworks from PyTorch, TensorFlow, Scikit-learn, and ONX. And also, part of this is where machine learning belongs, more of the productive services, the actual compute resources, such as Azure Databricks, Azure Machine Learning, and our data science VMs or machine learning virtual machines. Of course, with different types of infrastructure depending on what you need. If you need a CPU based machine, a GPU, or an FPGA. All right. So let's just go back on a typical end-to-end machine learning process. So when you do a machine learning or we try to solve a machine learning problem, the first thing you need to do is you have to prepare your data coming from your data sources, databases, files, wherever they are, right? And the next thing that you need to do is experimentation. So you need to experiment, build your model, train and test different types of models across different algorithms, different parameters, different features. And afterwards, after you've managed to figure out what's the best model, you register and start managing and tracking the performance of that model going forward. Then build your image. Let me just turn on the laser pointer. After you build your image, then you have to start deploying and monitoring the model going forward. And of course, you need to orchestrate all of this in one go. So this is the typical process of machine learning, and this is what also Azure Machine Learning is trying to solve to help you accelerate the preparation, experimentation, and deployment of the model. So with Azure Machine Learning, you have basically three major capabilities to support different types of users. You have AutoML UI, which means that you just need to drag and drop all your data sources and then let Azure Machine Learning perform all the machine learning development for you. So this is very useful for those citizens data scientists who's not really familiar yet with hardcore programming in Python or R. And we also have the visual interface. So this is more the drag and drop and the machine learning notebooks. And all of that can be managed through your GitHub or any Git repository. And in this particular session, we'll be focusing more on the automated machine learning UI because we want to accelerate the uh, problem solving, especially with the most common use cases such as churn, risk modeling, and so on. Plus, we'll also show you how to do it as well via Azure Machine Learning Notebook through the SDK. So within Azure Machine Learning, it has basically multiple components, which I'll explain later on what it is. So you have your workspace, you have models, experiments, pipelines, images, deployment, data stores. Once I do the demo, we will go back to this page again. Okay. Then within Azure Machine Learning, this is how it looks like. This is the Azure Machine Learning Studio. And this is how the automated machine learning looks like. It's basically a three-step process. You just need to select your data set, configure on how you want to run it, and then do the task type and additional settings, like what are the feature engineering that you intend to use, the algorithms, how long it will run, and so on. So that it will increase the productivity on your end, because rather than you iterating different models and different algorithms multiple times, you just need to pick and choose what you want to test and run, and then Azure will just provide you what's the best possible model based on the data set that you provided. Plus, it also has features for explanation and responsible AI solutions. So overall, I think there are six major features that AutoML is trying to solve. One is data pre-processing. So data cleansing, as well as filtering and imputation and so on. We also have feature engineering, which is also one of the most time-consuming part, right? Especially these two, data pre-processing and feature engineering. Around 70% of the actual work is actually dedicated to this first two steps. And apart from that, you also need to do some algorithm selection, hyperparameter tuning, recommendation of what's the best model based on the key metrics that you've chosen. Then afterwards, you need to interpret and explain why did the machine learning model come up with this decision making. So these are the six features that AutoML is trying to operationalize on your behalf, rather than you doing all of this one by one. Because let's take an example of if there's no AutoML, it's really time consuming. Let's take an example of a car. Let's say we wanted to know how much is this car worth. So in a typical machine learning scenario, you basically need to consider three key areas. You need to consider which features, which algorithm, and which parameter. And this is where you're going to pick up all the types of permutations you need to do in building your machine learning model. So which features? So you have your mileage, condition, car brand, etc. So these are the features that the machine learning model can possibly use. Then you also have algorithm from gradient boosting, k nearest neighbor, like GBM, and so on. And remember that each of these algorithm has its own set of parameters. So gradient boosted tree has its own parameter, SVM has its own parameter, like GBM also has its own parameter. And if we looked into this, okay, so you typically need to choose your features, choose one algorithm, then adjust different parameters. Then you come up with a model, 30%. Then you need to reiterate again because it's just 30%. Then you try k-nearest neighbor, try to do hyperparameter tuning again, then you have 50%. And it's very inefficient if you do it again over and over again, right? It's really, really time consuming. So what AutoML does is you give them the set of features, set of algorithms that you wanted to try. Then based on the set of algorithms, you'll give AutoML the power to pick and choose what is the most optimized hyperparameters to be used in your machine learning model. So how it looks like. So all the features will be chosen depending on the algorithm used and then the parameters, and then you have a set of models built after a few minutes or a few hours. Then at the end, you're gonna have 95% as your preferred model. So what AutoML does, it actually accelerates the model development. You just need to provide the input, provide the goals, what you wanted to achieve. Is it classification, regression, or time series forecasting? What are the constraints? By constraints is what features, what's the key metrics, what's the time to finish the model, and so on. Then AutoML would just pick and choose on its own. Then at the end, it will come up with the most optimized model, and this is the one that will be recommended to you. So rather than you going through this iterations or permutations, you have the AutoML do it for you. So by having that, you will have as well a unified model management because you can see all of the models that was already been built, and you'll be able to track each version of that and all the artifacts and other assets involved in the model development will also be available. So let's now go to demo. If in case you have a question, feel free to let me know. All right, so we'll go to the demo. So for the demo scenario, let me just go through the flow. So I have a diabetes data set, which I stored in, or which was stored in a REST API. And from the diabetes dataset, it will be read by Azure Machine Learning. We'll do AutoML. We'll do a deployment in Azure Container Instance. And then from Azure Container Instance, I actually built a React app that then access the API from the container instance through API management so that we'll be able to see the prediction. So we'll use this path for training. So the first thing that we'll do is reading the dataset, AutoML, then deployment. All right. So this is how Azure Machine Learning looks like. So you have three major capabilities. If you're familiar with Python or R, you have your notebook. Then you also have AutoML Designer. Then on the left side, same goes. You have the different types of authoring features from Notebook, AutoML, and Designer. You have the assets and management of the resources. So before I go to the actual AutoML, let's just focus first on the resources required under manage. So the first thing you need to have is a compute. So you have different types of compute available in Azure ML from a single compute instance, just like what I have. If we go here, it's a standard DS11 with 2 core, 14 gig of RAM, 28 gig of disk. So this is good if you're only starting to experiment and doing your initial model development. Then you also have your compute cluster if you need a cluster level compute. So with cluster level, in this particular cluster, I currently have 3 active nodes, but the good thing about it is you can scale it up and down even to a minimum of 0 so that if it's not being used, then you don't need to incur additional payment. So that's another type of compute cluster. Then you also have inference cluster, which is more for once you deploy it under Azure Kubernetes service, and some attached compute for some sort of external compute outside Azure ML, such as Databricks, Data Lake Analytics, HD Insight, Synapse Spark Pool, and Virtual Machine. So for Azure AutoML, we only need a compute cluster and a small compute instance when I show the SDK later. So afterwards, we have the data store. So within the data store, this is where we actually link or store the data. You have an option to store your data in blob storage, file share, data lake, or any other databases. This is if you want to integrate your data source and be able to use AutoML. Then you also have your data labeling service. This is more for computer vision and object detection problems and link services. This is more for linking it with Synapse. And let's go to the data assets. So as I mentioned in the diagram, we'll be using diabetes dataset. So within the diabetes dataset, this is the dataset that I have, diabetes dash data. It actually comes from a a web URL. So it's also another option of where you want to get or consume your data. So how it looks like, go to consume, explore. I think it has, if I'm not mistaken, around 10 variables from patient ID through to diabetic. So what we wanted to predict is whether or not this particular patient is diabetic or not. So it's 0 or 1. It's a classification problem. And with Azure ML, you can also see and generate some profile. So I've already pre-generated the profile, and you can check the distribution of the data, the mean, the max, if there's any missing values, and so on. So in this particular data set, there's no missing value, and yeah, it generally looks fine. And then if you want to go a bit deeper on the actual column or actual variable, you can also do that to get more profiles of the data. So this is our data set. It's called diabetes data. Then we also have a concept of experiment. So if we are building, for example, a diabetes machine learning model, you would want to group your model iteration under a single experiment. So it's a collection of different model iterations that you have, so that you'll be able to track the result of each of the model after it's completed. Then you also have modules later on if you want to reuse your code, pipelines for your data and feature engineering pipelines. Then models, this is the actual image of your machine learning model that you deployed in an endpoint. So as you can see, the good thing about it is you will be able to track the version of your Azure ML and also verify the actual performance, the AUC, and then you can pick and choose whether or not you're gonna deploy it in production. If in this instance, for example, from version 1, it's the AUC is 0.88, but was dropped to 0.87 on version 2. So you can have an option not to deploy it and do a retraining again when you feel like there is a performance degradation in your model. Then you also have your endpoint. So this is where we'll deploy the endpoint later on based on this diagram. So this is the Azure container instance. All right, so we'll go to the actual AutoML. So I've already pre-run the AutoML because it takes a while. I think it's minimum of 15 minutes to maximum of 15 minutes minimum run if you want. But we'll start a run again. So the first step that you need to do is select the data set. So we'll use diabetes data. The next thing we need to do is press next. Once you press next, what will happen is it will start checking the actual data set. So, oops, like that. So diabetes data, click next. Next thing we need to do is select an experiment. So I want to track this particular AutoML run on EXP AutoML demo. Then we need to choose the target column, which is what we wanted to predict. So we wanted to predict whether or not the patient is diabetic. Then we select the compute cluster. Since I already have a compute cluster with 3 nodes, I'm going to choose that. Then what will happen is you just need to press next. And from there on, you can choose what type of task type that you wanted to do. Do you want to do classification, regression, or time series forecasting? So since the problem that we're trying to solve is more of whether or not the patient is diabetic, then it's more of a classification problem. Afterwards, we'll do the additional configuration. This is more to choose what is the primary metric that you wanted to be able to figure out the best model. So we have 5 possible primary metrics from accuracy, AUC, macro recall, precision, and precision score weighted. So in this particular experiment, we'll try to use a recall because we wanted to maximize the number of patients that we predict that has diabetes. Then the next thing is that the next option is whether or not we wanted to explain the best model. So I would suggest just to keep this ticked so that you will see the feature importance and why and how the machine learning model basically decides at the back end. Then we will choose which models we want to block or we wanted to exclude from the training. So let's say for this example, we don't need logistic regression, we don't need SGD or naive Bayes. Let's say we just want to keep all the gradient boosted trees. So like GBM, gradient boosting, XGBoost. So we'll just keep it at 3 algorithms. Then the exit criteria, this is how long the job will run. So by default, it's 3 hours, but I think you can have it as low as 15 minutes or I think 30 minutes. So let's just say I just want to run it for 30 minutes. So that's 0.5 hours. Then you can also choose the score. So what happens is if after 30 minutes, uh, I've done 100 models, Azure ML will just choose the best model out of those 100 models. Or if any of the metric threshold score was met. So let's say if you put 1 here, if the recall score is 1, then Azure machine learning model will stop and will choose that model. But if not, if you don't want this to be part of the exit criteria, then just leave it blank. Then you also can perform different types of validation from automatic. You just let AutoML figure that out for you. K-fold, Monte Carlo, train or validation split. So I'll just keep it auto. Then the last configuration that you need to do is the number of concurrent machine learning models that will be trained in parallel. So by default, it's 3 because the number of nodes that we have or that I set up was 3. But you can opt to choose 1 or any other number. All right, then afterwards, just press save. So we have all of this already done. Then we'll do view featurization settings. So this is more on how you want it to be, how you want to treat each individual columns in your data. You can include or exclude specific data set or specific columns. So let's say I want to exclude this and want to include the rest of these variables. Then you're free to choose what type of feature it is, or you will let AutoML do it for you as well. And for imputation, if there's any missing value, what's your preferred method of imputing the data? Are you going to use mean, most frequent, mean, median, mode, or fill it with a constant? Or you can also let AutoML figure that out for you. So we'll just keep this all auto. Okay. Then afterwards, we're done. And then we just need to press finish. So it will start running through all of those steps from feature data processing, feature engineering, actual machine learning model building, including hyperparameter tuning. Yeah, sorry for that. I think that this display was very small in the presentation. All right, so once it's done or once it's running, I actually recreated an AutoML model. So once it's completed, what will happen is you have your data guardrails, which is basically the different steps within your data and feature engineering process, from validation split, class balancing detection, uh, balancing detection is whether or not you have an imbalanced data set, because you will treat your data a bit different if it's imbalanced. Imbalance means that the number of yes and no is not proportional to each other. It's not almost 50-50. Then you also have missing value or missing feature values imputation. So if you want to impute specific values here, plus some high cardinality features. So all of that will automatically be checked by AutoML. Then you'll notice that it actually did at least 49 types of machine learning model for you. So each running roughly a minute per model. So from truncated SVD wrapper with XGBoost through to the best one, which is an ensemble of models with this particular metric, 0.89 normalized macro recall. So these are all the models that has been built with different types of feature engineering techniques, from standard scale wrapper, max upscaler, and so on. But all of that you don't need to worry about, because that's something that AutoML will do on your behalf. So let's say we wanted to inspect the best model, which is stack ensemble. So within the stack ensemble, we'll be able to check the metrics, individual metrics, not just the not just your key metrics, which is the normalized macro recall, but other metrics such as accuracy, AUC, area under the curve, Matthews correlation, etc. So you can pick and choose the different types of metrics because it's already pre-calculated for you. And you have your different graphs from precision recall curve to ROC and so on. So this is to inspect the actual performance of your model. So it's already predefined and pre-calculated. And a while ago, I think I mentioned that I've ticked the select best model, explain the best model. So that's why you'll notice that the best performing model has view explanation link. So if we clicked on this link, you'll be able to see the explanation on how the model decides. So if we go to aggregate feature importance, and let's say the top 7 features. So you'll notice that the main predictor was number of the pregnancies, age, BMI, serum insulin, plasma glucose, triceps, and the diastolic blood pressure. So it shows you the feature importance at the aggregated level and at the individual data point levels. That's in the individual feature importance. So you can randomly choose your data. Then down below, it will show what are the contributing factor for it to decide. Let's say, I think this one is a diabetic patient. I think it's based on BMI, BMI, pregnancies, serum insulin, triceps, and age. These are the top 5 contributing factors for this particular patient. So yeah, so just to recall, within AutoML, it will choose the best performing model based on your primary metric. Then within the best performing model, it will also create an explanatory model for you to see the performance and the contributing factors for that decision making. Any questions so far? None?
No. So far,
Nope.
no questions.
Yep, no worries. Okay, so the next thing that we'll do is we're gonna deploy the model. So for us to do that is here. So you choose the model that you wanted to deploy, so that we'll be able to create an Azure container instance. So this is the endpoint of the prediction or the inference capability. Okay, so we'll choose stack ensemble, and we'll just need to press deploy. So when we press deploy, we just need to give it a name, AutoML diabetes endpoint. Let's say I've already pre-created it. That's why it's saying that it already exists. Then the compute type, whether you want to deploy it in a Kubernetes cluster or a container instance. So in the example that I'll be showing, I just deployed it in a container instance since it's a very small uh, prediction Docker container. Then you choose whether to enable authentication and other advanced features from SSL, the number of CPU, the memory or the RAM, and so on. So we'll just keep it at default. Afterwards, you just need to press deploy. And then when you go to your endpoints, it will be shown here. So you have AutoML diabetes endpoint. So it will provide a REST endpoint for you that you can use in testing out with your own data. And on top of that, you can also it actually can also do some testing on this end, or if you are writing your own application via C Sharp, Python, or R, it also has some predefined script. Which I'll be showing that as well later on, and some deployment logs. All right. Then if we're gonna go back to the experiments, within the experiments, so this is where I'm tracking the diabetes AutoML. So these are all the runs that I did before, and it was able to track each of the individual runs, how long it takes, what's the compute target, and what's the best performing features that I have, or feature model that I have. We just go to the actual endpoint. You can just copy this and we'll show that later on. And the next thing that I'll be showing is, so what if you don't want to use this graphical user interface? You wanted to use a notebook instead. So what you can do is you can go to the notebooks and you can use the Azure Machine Learning SDK to build your own AutoML. So same principle, but in a programmatic way. So you just need to connect to your AutoML workspace. An example. Then afterwards, you just need to upload your data, or if the data is already existing, then it will say that the data is already registered. Not sure why it's taking a while. Just restart the kernel. Then afterwards, you just need to create your compute cluster. But if the cluster already exists, uh, it will just ignore this particular line of code. Okay, I think it's done. Then data is already registered. Then you just need to put your cluster name. So it should say that the cluster already exists. Then you start configuring your AutoML features programmatically. So you can drop a column. I dropped ID. You can drop or determine which algorithms you want to exclude during the experimentation. Then some AutoML configurations. The name of the experiments, or the name of the AutoML, classification type, timeout, basically the same feature that we clicked a while ago, but this is more in a Pythonic way. So once it's done, provide all of these configurations, normalize macro, amount of concurrent iterations, etc. Then the next thing you'll do is just run or submit the model. So I think we have a question. If I created it in AutoML, will it have an automatic notebook equivalent? If not, can I convert it to a notebook? So I believe it doesn't automatically convert it into a notebook, but all the artifacts that you need to build a notebook will be in the AutoML feature. So if we go back to EXP experiment AutoML, all the outputs of each of the individual models will be here. So all the artifacts, the pickle files, etc., so that you can replicate it via notebook if you want. But there's no direct conversion to a notebook. Even on the individual model, you also have all the programmatic artifacts as well of what was executed by AutoML. So I'll just quickly go back to the notebook. So it's starting to submit and perform the experiments. So it will take a while to do that. All right. So this is the method via notebook using AutoML. Then the next thing that I wanted to show is the actual usage or the prediction type, which is the blue line, this one. So within the diabetes endpoint, I think we need to copy the REST endpoint or use one of these codes. So I actually prepared a Python notebook for this. So using this actual script. So we'll do first the notebook way. So we'll just go to automated ML scoring. Automated ML scoring. I just actually copied the code. Then just run the code. Put in your data from here. Then it will show you the result. So given this data set from this pregnancy, plasma glucose, and all other details, it actually predicts that it's potentially the patient is diabetic. So this is if you want to embed it within your own Python application. But if there are also other alternatives, so you can consume it via C# or even via R, depending on where you want to build your application. Or if you want, if you're familiar with the Postman, this is where you submit get post a RESTful request to an API. You can also use that to trial this API. So you just copy the REST endpoint, paste it here, then put in the header. Content type is trying to zoom in. Yeah, content type application slash JSON. Then you put in the body. You can have each of these metrics of this list is a patient data. Then we just need to press send. It will provide. So patient 10 million is possibly diabetic, whereas patient 2 is possibly not diabetic. So this is just one of the ways to consume your API. But then just for the sake of completion, we have the Azure container instance, and I actually built a React app. So this is how the React app looks like. So it's a form where you just need to put all your details, then it will check if you're diabetic or not. I need to create an API management. The reason why I need an API management, I think it's because of the cross origin resource sharing. So since the web application that I built, the AutoML Diabetes, and the API, which is Azure Container Instance, do not share the same origin or the same domain, I need a cross origin request. Hence, I need API management to take care of the uh, course or cross origin resource sharing. So I built an API management in here. Then within the API management, I just registered the diabetes endpoint and enable CORS. So I enabled CORS for my local host 3000. Then within the diabetes ML, I just need to create a score post operation. The same as what I have in my Postman. It's a score as well. And it's a post request. Then from there, I can have that API. So it will create a separate link or a separate where's that API for me or gateway. So Azure Demo API Management, Azure.api that I can embed in my React script. So this is just a sample React script. You have your URL here, and then the post request or the URL, which is score, and just need some subscription key just for authentication purposes. Then afterwards, then I was able to build the AutoML, have that, and add some values or input some values from these different fields, and then I can check whether I'm diabetic or not. And I can change some of these values. Let's say the BMI is 30, then the result changed. So this is one way to consume the application. So just to recap, I built and deployed the model in Azure Container Instance. I built API management to allow cross-origin resource sharing. Then the React app will access the container instance via API management, and the user just needs to input the data so that I'll have this particular small applications. So yeah, so this is how the AutoML works. So let's see where we are at right now with the actual AutoML. So it's still running. So it's still performing some of the test. I think it will keep going over the next 15 minutes. It's just been running for 18 minutes. But afterwards, you can do the same thing of deploying it, or even if you submit it by Jupyter Notebook, you will also have the same features under the Azure ML platform. So yeah, I think that's it for me. So in this particular session, we managed to use Azure AutoML feature to build and experiment different algorithms, hyperparameter tuning, feature engineering. Afterwards, we deploy it in Azure Container Instance and consume it using a React app via API management service. Any questions?
All right. If you have any questions, you can put it on the chat. We're gonna give a few minutes before for you to push your questions. Let me just check the stream if there's any questions. Going once. If they have if they want to reach out to you, or if they want to ask you some questions afterwards, how can they reach you?
They can connect to me on LinkedIn and then send a message. More than happy to answer their questions. I'll just post my LinkedIn profile here.
All right, we have a question from Sanjeev. Uh, is there a good way to write results back to reconfig the data model?
What do you mean? Write the results back to reconfig the data model.
So let me unmute PO if that is okay.
Yeah, sure, that's fine.
So thank you very much, Emil, first of all, for the great conversation. So the point is that let us say we are doing a customer service survey, so we have a whole bunch of like commentary from, bunch of different students as an example in the educational institution. And what we're actually trying to find out is, let us say, typical, right, cognitive services, key phrases, sentiment, things like that. Now, as we hook like literally, I mean, we compose a data model from the survey. We take, that one column that actually has comments, we hook it up to cognitive services. As we bring back the data, we clearly want it to reside within that data model that we've actually constructed, because it's got all like, it's got the proper fact table, it's got all the master tables and things like that. And we want the results to sit within the confines of that. Yeah, you follow me, right? So what is the most elegant way of doing that?
I think if you correct me if I'm wrong, I think if you wanted to use the data model that you have, I think you need to create some sort of a master data, a presentation layer on top of your existing data model that you can use to ingest directly to the prediction pipeline or used for the training pipeline. Because you just need a single denormalized table when building a machine learning model. Did I answer your question?
Got it. In the interest of time, got it. I'll follow up with you perhaps later. But thank you very much for sharing your LinkedIn profile. Much
No
appreciated.
worries. Yeah, so you can follow me or connect to me in my LinkedIn profile. It's Emil Lawrence Pastor. Awesome.
All
Awesome.
right. Okay. Any more questions? Going once? All right.
Awesome.
Thank you, Emil, for your very informative session.
No
Do you have
worries.
any last words for attendees?
Yeah, so yeah, thank you very much, Pia, for the invitation. I think yeah, it's good to start exploring AutoML. I think as more and more organizations will start considering this to solve their most, I think their most common problems from churn modeling or any marketing, campaign analytics, marketing analytics type of problem, risk, so that you can focus your effort on building the more sophisticated model in more challenging use cases. Then you'll just let the most common problems be run under AutoML.
All right. With that, I would like to thank you in behalf of the APAC Azure Data Communities for your time.